Welcome, and in this video course we are looking at the CyberOps Associate version 1 course. This course is going to cover the skills and knowledge needed for successfully handling the tasks and duties, responsibilities of an associate level security analyst working at a security operations center. The goal of this video series is to help prepare learners for the Cisco 200-201 certification that's focusing on understanding the Cisco Cybersecurity Operation Fundamentals course known as CBROPS. Module 23, Endpoint Vulnerability and Assessment. So in this module, we are looking specifically at the assessment of vulnerabilities for our endpoints. That means understanding how the vulnerabilities are going to be affecting them. Looking at things like the Common Vulnerability Scoring System, the VCSS. We're going to talk about Common Vulnerabilities and Exposures, CVEs. We're going to be looking at profiling of our devices, both the network and server and other endpoints. We're going to talk about securing different types of devices, and we're going to wrap it up with information security management system, and that's going to be more of the protection of assets. Alright, so let's look at this network and server profiling. So essentially, a profile provides statistical baseline information based off of the characteristics that that item uses. For example, a server, we know it's going to be a specific type of OS. We know it's going to have a very specific type of profile, such as ports that are going to be open, and there's going to be a certain average of time between connection and termination, session duration, same thing with total throughput, total bandwidth availability. Often it's going to have more resources, space, memory, and processing power, but we can also start looking at like traffic type, and that's going to be again based off the port numbers and the ports used. This allows us to start building a profile off of the network devices, off of the network flow. And all of that is going to be unique to a given network, with the specific server in mind on the network. We're going to be looking at the profile, the baseline, and that's going to be looking at the ports that are actually listening, not the ports, not the port numbers that are actually having data transgress the network, but actually listening and responding ports. Accounts, whether it be logged in user or service accounts, things like that, as well as there should be a certain level of software involved, meaning that each OS, each server specific OS is going to have certain environments that, well, they run in. If we're dealing with a web network, or we're dealing with a web server, for example, we know there's going to be a specific set of applications running for that server, whether it's Apache or IIS or Nginx. There are going to be a very specific environment based off of the type of data going to and from that server. Alright, so what does that have anything to do with protection? In reality, when we understand the profile, when we understand the traffic to and from, when we understand the baseline, we understand what the flow of data should look like. And that allows us to start building an anomaly detection based system. We could do that for the network, for example. Network behavior is described as the type of data that's flowing through the network that's known, that is seen repeatedly. We have ways to analyze that, big data analytics, but the interesting part is that anomaly detection will identify what machines, what servers, what network flow is abnormal, and that can help identify possible infected hosts that otherwise you would not have been able to find. And this is a very simple algorithm illustration that would show you how network flow could be used to identify and possibly set an alarm based off of the detection of network flow. Because again, we're looking at patterns. That's the purpose of our profiles, is to look at patterns. Within network vulnerability for testing, we have things like our vulnerability assessment, our risk analysis, our risk assessment, our pen testing. All of these provide very specific functions. A risk analysis identifies our risk for the overall organization, as well as for us to define likelihood of events occurring. That could be an internal or external risk management or risk flow. Vulnerability assessment, that's going to be things like port scanning, patch management, patch scanning, as well as vulnerability scanning for both services, for profiles, and for general structure of our network. For our vulnerability assessment, you're going to use tools like Nessus or the Microsoft Baseline Analyzer. You could use OpenVOS. OpenVOS is probably the cheapest of the options, but it's probably the hardest to set up. But again, all of these are looking for vulnerabilities in configuration as well as host profiles. Lastly is our pen test. Our pen tests are going to be looking to see how someone could gain access to the network or to the system, and that's going to be using tools like Core Impact, actually having offensive security teams or ethical hackers try to pin your network, using tools like Metasploit. So all of these kind of help build your profile structure within your organization. Moving past that, we have to have a way to score our systems. We have to have a way to actually make it more tangible. Well, we can't just say, oh, our network is vulnerable. We need something that's more structured than that. And that is where we get the Common Vulnerability Scoring System, or CVSS. Alright, so understand that the CVSS is a risk assessment tool. And if you go to things like first.org, you can find the specifics on the scoring system. Again, it's used for risk assessment, and it's specific to used to convey the attributes and the severity of vulnerabilities to third parties or to other parties. It provides a standard platform for reviewing and understanding vulnerability scores. First is the forum of incident response and security teams, and they have actually created and developed this CVSS scoring system for a global-based adoption. So, okay, what does this really mean? This means that when you have multiple entities throughout the country, throughout the globe, and you're talking about risk, you have a scorecard, you have a way to compare apples to apples, regardless of the organization that you're in, regardless of the country that you're in. This platform gives us the standard scorecard for ranking our vulnerabilities. Alright, going past that is our metric groups. How do we actually organize our groups? There are three main groups: the base metric, the temporal, and the environmental. The base metric represents the characteristics of vulnerabilities that are consistent over time. Attack vectors, integrity or confidentiality or availability impacts, CIA impacts, user interactions, privilege, or the complexity of attacks. The temporal groups are going to be measures the characteristics of a vulnerability that has the ability to change over time, but not across the user environment. Code, remediation, confidence levels of our reporting. And then lastly, we have the environmental metric group, And this specifically looks at the aspect of vulnerabilities that are rooted in the organization's environment. Again, confidentiality, modified based, the availability requirement, the integrity requirement, sometimes the confidentiality requirement, as well as the confidence requirement. Confidentiality versus confidence when we're looking at a certain level of confidence in data availability. So that breaks down our three main metric groups within the CVSS. So again, if we're looking at the base metric, that's going to be our vector, our complexity, our privileges, our interactions, our scope, as well as our impacts for CIA. So within that process, what we would do is we would look at each of the main sections and we would use a calculator. Here they're looking at the CVSS 3.1 calculator. The calculator is like a questionnaire, and basically you go through and you will select the appropriate sections inside each of our base metric. And then later a score would be generated based off of the severity that is being rated in that area. And again, normally we would be looking to see the severity rating, and the lower the severity, typically the better. So the process is we go through the metrics, we do the base formula, and we get a base score. Then we get a temporal adjusted score. Then we get an environmental based score. We'd get a score for each of the major sections, and that will give us our overall score. Our overall score will tell us what our risk is. If we are in the low range between 0.1 and 3.9, if we're in the medium range, 4 between 6.9, or if we're in the high range, that's going to be anything between the 7 and 8.9 range, or critical is anything above 9. Normally, vulnerabilities that are above the low range are addressed and are mitigated. That way, they are keeping the overall risk to the organization low. Anything that is scoring higher typically is reviewed sooner than later because they are at the highest risk. So this gives us a scoring card. This gives us a way to review the contents, but how do we actually identify and organize them? And that is where our common vulnerabilities and exposures, CVE, comes into play. This identifies a standard way for researchers to reference vulnerabilities. So as a vulnerability is found, we would then use the CVE. Normally they'll assign a number to each new vulnerability, and we can search their database or their collection of information on that CVE. So we can look at CVE details. For example, if we know we have a Server 2012 machine, we could look at all vulnerabilities for Server 2012. And that way we could look at what vulnerabilities are currently out there. Again, the CVE detailed website provides a linkage between the CVSS score and the CVE information. They go hand in hand. So once you have a good understanding of the CVSS scorecards and the CVE information, we have an additional database for vulnerabilities, and that is the National Vulnerability Database, and that is organized through NIST.gov, and this utilizes the CVE identifiers, and they also provide certain score sheets as part of the CVSS, as well as other technical details, affected entities, resources, and things like that. Again, this database was to be maintained by the U.S. government through NIST, the National Institute of Standards and Technology Agency, so that we can understand what vulnerabilities are out there. Again, vulnerability management is huge, and this is one area where a lot of security professionals and network professionals don't really review. It's overwhelming, and again, it's a rabbit hole. So let's move on to securing our device management. So this is going to be looking at risk for our devices. So as we're talking about our devices and we're talking about risk, well, we need to understand there's multiple levels of risk. Normally, risk falls into 4 main categories. This is not a complete list, this is just the top 4. And this is the ways we identify risk. We have risk avoidance, risk reduction, risk sharing, risk retention. There's also things like risk acceptance. At a certain point, we could mitigate a certain level of risk, but at what point do we just accept a certain level of risk? So risk acceptance is not listed here, but that is definitely one type of risk. Risk avoidance is basically we stop performing activities that, well, allow for risk. Risk reduction are ways to reduce our risk. Risk sharing or risk mitigation, and that is where we can shift some of the risk to third parties. Insurance, great way to talk about risk sharing or risk mitigation. That would be insurance. And then risk retention, and that's going to be our risk acceptance. That's where we accept the risk and the consequences. Even though the name likes to change, in reality, this is our risk acceptance portion. Within our vulnerability, it's a life cycle. It's not a one and done type thing. We look at the steps involved, and there are typically 6 of them. We start with discovery, prioritize assets, we assess, we report, we remediate, we verify, and then we discover again. This is going to be the life cycle for vulnerability management. We discover the vulnerabilities, we prioritize our assets so that we can remediate the assets that are the most crucial. We assess them. We will determine with that assessment a base level of risk. We can also classify. Within the report, we measure the level of risk associated with that asset to the business. We might also develop a plan. We may look at what types of vulnerabilities are there and what happens if we leave the possible vulnerabilities. We prioritize a remediation. We essentially we repair or mitigate the vulnerability. We verify the risk has been the risk of the exposure of the vulnerability or the vulnerability itself has been removed. That's the verification process. We verify it. And then we start the life cycle over again. And again, this is a continual life cycle. This isn't a one and done. So now that we understand a certain level of vulnerability management as well as how we prioritize vulnerabilities and how we measure risk, we can look at the asset management. Again, this is a continual life cycle. This isn't a one and done. Asset management involves the implementation of a way to track the location and the types of assets on a network, and that's going to be across the enterprise. Some of the tools and techniques of asset management are typically some type of automated discovery for inventory. That way you can get an up-to-date list of what's on the network, and you can get details such as the operating system, the patch level, and as well as the application installations and their version numbers as well. There could also be an articulation of the desired state for policies and planning and procedures depending on the type of environment. For example, in a Windows environment, you may have Active Directory. Within Active Directory, you may have group policies that are being applied. That would be the articulation of a specific state based off of group policies. And there are something similar for Linux and for our Apple friends as well. We also need to look at the identification of non-compliant authorized assets. Again, any asset that's on your network you need to be aware of, as well as their level of risk. Devices that are on the network that are a high risk value normally need to be isolated and then remediated so that they could be better protection. And again, remediation or acceptance of that device state is possible, but often we want to isolate our lower hanging fruit until they are at a certain level or a certain profile state to ensure a certain level of security of the devices on the network. For example, if you have an out-of-date Windows XP machine and it's on the network, well, you'd look at, well, why is it on the network? 1, is this necessary? 2, if there is a legitimate reason why it needs to be on the network, then you accept the risk. Otherwise, you try to remediate it by maybe updating it from Windows XP to Windows 7 or Windows 10, or you find another way to secure it the best that is reasonable. And again, this process is a ever-evolving, ever-growing type plan, so when you're done, you start the process all over again. So since we're talking about assets, we do have to talk about our mobile assets. So we have seen an increase in our mobile device management, also known as the MDM system. So Cisco Meraki does have a system manager that does allow the security personnel to configure and monitor and work on mobile clients from the cloud. Again, this is going to be an increase of mobile devices that we can centralize in the cloud for managing of those devices. Several of them also have additional third-party tools that could be downloaded and managed. For example, SolarWinds has one for managing mobile devices. Now you are paying a per device fee for managing mobile devices, but mobile devices are part of the network, even if they are not always part of the organization. For example, you may have an executive in an office who, while at the office, is using his mobile device, but they may travel and that mobile device goes with them. That mobile device being like a cell phone, for example. So all of those need to be accounted for, because when we talk about asset management and asset protection, most people just think, oh, a tablet or a laptop, but your mobile phone is a computer nonetheless. So your device also needs to be protected. For our configuration management, we have things for configuration tools like Chef and SaltStack. All of that allows for configuration management, and we have to have a framework through NIST on focusing on how to define the overall management for our mobile devices. When we look at our end devices, we have a patch management requirement often, and that involves seeing what's on our network, what devices are patched, what version of the applications are patched, and all of this is required through different compliances, part of SOX and part of HIPAA. Even if we do not understand all of the nuances of the compliance, most major security compliances do have a asset management and patch requirement so that you can see what assets are on the network as well as what vulnerabilities they are tied to. In this example, we can see desktop node health, and we can see that there are computers that have update errors. We can see how many devices are on the network. We can see what applications and the severity of the patch status of those applications all through this dashboard. Patch management is crucial, and yet this is one area where oftentimes people fail. Some patch management is agentless, some of them are not. Here we have our different IDSs, or our other agents that are on machines that then actually call out to a patch management server, and that determines the status of the patches. We could also have that patch management server actually approve the versions and would deploy the patches if necessary. And again, this is typically an agent based, so that the agent on the machine calls out to that patch management server to verify what's going on. We also have an agentless version, Windows environment, where we have a Windows patch management server, and periodically it pushes approved patches to our end devices. We also have a passive network monitoring that will passively look at the network and will determine what patch values all of the machines are at. This approach is not very effective in keeping things up to date. It's very effective for trying to determine what software is on the network. Alright, the last major section is about information security management systems. So the first one is going to be our security management system, typically referred to as an ISMS. And this consists of the management framework used to identify, analyze, and address all risk of the organization. So that's going to be looking at the capability, the technology, the processes, the people, the culture, all of that put in together. And then we have a life cycle phase that we implement. We plan, do, check, and then act. And then again, this is a life cycle so that we keep repeating it. And all of this, again, looks at the culture, people, process, and technology and capability of the organization to see the model of protection and security for that organization. When we're looking at the ISO 27001 and 27002 examples, when we look at that plan, do, check, act, that's going to be like understanding the objectives, defining our scope. The do is going to be implementing plans, establishing and enforcing policies and procedures. The check will be monitoring. The act will be actually continuing, involving the process, corrective action, preventative action, action in general. And this becomes very important when you're trying to meet these international standards. While the ISO 27001 and 27002 are really big compliance checkboxes, these typically involve a heavy investment in the organization, and most organizations quite aren't there yet. We also have, within the US, we have our NIST cybersecurity framework, and that's identify, protect, detect, respond, and recover. And this is the overall general cybersecurity framework used to protect organizations within the US. And again, this is just a simple framework, not an in-depth framework. All right, so that brings us to our summary. We've looked at our profiling for network and devices. We looked at our scoring systems, the CVSS, the CVEs, and then the vulnerability databases. We looked at the vulnerabilities as well as risk management. We looked at risk, understanding risk acceptance versus risk avoidance versus risk mitigation. We looked at some of the simple frameworks at a very high level, the ISO 27001, ISO 27002, as well as our NIST standard. And more importantly, we looked at patch management as it relates to our compliance. So that is actually our last section in a nutshell. So again, this was all about understanding vulnerability and risk for the end device. Any questions or anything, please feel free to reach out. If you have any questions or anything, please feel free to reach out. Again, with this material, being able to ask questions and discuss some of the topics in the lecture help build long-term retention, so do not be afraid to communicate with this topic. Again, I'm here if you need anything. Thank you.